Today, one of our topics is to use inductive reasoning. So our essential question is, what is inductive reasoning and how can I use it? First off, some key terms for you. Conjecture. A conjecture is an unproven statement that is based on observation. So what do you observe about a situation? It's not proven, you just make a conjecture. It's like a hypothesis. Inductive reasoning is the process of finding a pattern in specific cases and writing a conjecture for the general case. And then lastly, a counterexample is a specific case for which a conjecture is false. So it proves a statement incorrect. Make and test a conjecture. So we're making an unproven statement based on observation. Numbers such as 3, 4, and 5 are called consecutive numbers. Make and test a conjecture about the sum of any 3 consecutive numbers. First, we want to find the pattern. So if we do 3 plus 4 plus 5, start with those, that gives us 12. We try, let's just move up one. Let's just do 4 plus 5 plus 6. We get 16. Oh, my apologies, 15. If we keep moving up, we can do 5 plus 6 plus 7. And we get 18. We could keep this pattern going for a while if we wanted. 6 plus 7 plus 8. And we get 21. 7 plus 8 plus 9, we get 24. So if you notice, a pattern is starting to form. Every time we change the numbers, we're going up by 3. We're adding 3 to this total, which means we got something going on with 3. So if we look at the middle number in our pattern, what's 4 times 3? Well, 4 times 3 is 12. What's 5 times 3? 5 times 3 is 15. What's 6 times 3? 6 times 3 is 18, and so forth. So our conjecture would be that the sum of 3 consecutive numbers, and I'm going to abbreviate, is 3 times the middle number. Test your conjecture. Now this one we want to do it with like really large numbers. So let's just do like 231 plus 232 plus 233. If we add those together, we get 696. Now let's test that. If we take 232 and multiply that by 3, we get 696 as well. So our conjecture is holding true for now. Find a counterexample. Remember, that's a specific case that shows your conjecture is false. So a student makes the following conjecture about the sum of 2 numbers. Find a counterexample to disprove the student's conjecture. Conjecture is the sum of 2 numbers is always greater than the larger number. So, for example, if we say 6 plus 9, that means your sum should be bigger than 9, which it is 15. Can we find a counterexample? I'm going to give you a moment to think about this before I tell you mine. See if you can come up with your own counterexample. All right, now that I've given you some time to think, if we think about negative numbers, if we did -2 plus -3, that's going to give us -5. However, -5 is smaller than -3, and it's also smaller than -2. So when you go into the negative numbers, this is when this conjecture would be false. All right, next piece is analyzing conditional statements. So our essential question for this part is, how can I write and use conditional statements? We're going to be using this a lot, so make sure you're really catching on to this piece, all right? The parts in blue are what you fill into your paper, so I'm going to read through this. Conditional statement, a logical statement that has two parts, a hypothesis and a conclusion. If-then form, it's a very popular form we're going to use a lot. Hypothesis follows the if, and the conclusion follows the then. Example, if it is raining, then there are clouds in the sky. So it is raining is your hypothesis, and there are clouds in the sky is your conclusion. The opposite of the original statement is called a negation. So that usually just adds the word not. So if we have a statement, the ball is red, your negation would be the ball is not red. Statement, the cat is not black, your negation would be the cat is black. So just the opposite of the original. Verifying statements. Conditional statements can be either true or false. So if they are true, you have to prove the conclusion is true every time the hypothesis is true. False, you just have to provide only one counterexample, which we talked about earlier. Related conditionals. We have three. Converse. You exchange the hypothesis and the conclusion, so you flip them around. Inverse, you negate both the hypothesis and the conclusion. Contrapositive, first write the converse, then negate both the hypothesis and conclusion. So contrapositive is kind of a combo of a converse and an inverse. So for practice, we are going to write 4 related conditional statements. So our statement is the guitar players are musicians. So for if-then, we would say if you are a guitar player, then you are a musician. We put the hypothesis in front and then the conclusion at the end after the then. So let's talk about it if this is true or false. If you are a guitar player, then you are a musician. If you are a guitar player, if that is true, then yes, it would be true that you are a musician. So both our hypothesis and our conclusion are true, so this statement would be true. Converse, so converse, you flip around your hypothesis and your conclusion. So we're flipping the if and then part. So we're taking the musician piece, putting it at the beginning. If you are a musician, then you are a guitar player. Well, if this is true, then all musicians would be guitar players, and that's not true because it's saying if you are a musician, then you play guitar. Well, no, if you're a musician, you could play the drums, you could play the clarinet, you could play the piano. So this would be a false statement. Inverse, so we take our if-then statement and we just negate both the hypothesis and the conclusion. So if you are not a guitar player, then you are not a musician. All right, so for this one, true or false, if you are not a guitar player, then you are not a musician. Well, we could also say, like, if you're not a guitar player, you could be a piano player, which would then make you a musician. So this statement does not hold up. This one would also be false. And then our last one, contrapositive. If you are not a musician, then you are not a guitar player. So this is taking the converse, remember we write the converse first, and then negating both pieces. So if you are not a musician, then you are not a guitar player, and this would be true, because if you are not a musician, that means you play no musical instruments, so therefore you would not play the guitar, because you do not play any musical instruments. Last one, equivalent statements. 2 statements that are both true or both false. So examples would be the if-then statement and contrapositives, converse, and inverse. I'll come back to this, but if you look, this shows in what we just did. Our if-then statements were both true, and our converse and inverse were both false. So they are equivalent statements. Then a biconditional statement is a statement that contains if and only if. So when a conditional statement and its converse are both true, you can write them as a single biconditional statement. And we'll talk more about this in the practice that we do in class. That's all the notes I have for you today. Thank you for watching this video, and please subscribe to my YouTube channel.